Kind greetings to you all. This is Mwalimu Arnold Sekago. We are back with our item here on bonding. Part C has been dissected exhaustively. Now we are on part D. Explain one environmental impact associated with any one. So they wanted you to identify one of the mentioned four substances. Consider only one of the mentioned four substances, and you explain its environmental impact. Only one. However, what I'm going to do, I'm going to give environmental impacts for all those substances so that I give you a clear picture of all of them. So below are the side effects. We start with our first substance was potassium chloride. Recall that in the previous videos, now if you are watching this for the first time, I'll refer you to the previous videos. In the previous videos, I have said that most ionic compounds are salts. Most ionic compounds are salts. Do you know what salts do? When you put a salt in water, it will result in salty water. Most ionic compounds are salts. So if you put a salt in water, it will result in formation of salty water. Now, if that water has been having fish will get suffocated. That is one point. If you put a salt in water, water will become salty. If there is a fish in that water, fish will become suffocated. Another point, these salts do not decompose. They do not decompose. If you put it on land, it is a compound that has been made artificially. It is not organic. So if you deposit it on land, it will be non-biodegradable. Therefore, it will affect soil structure. How many points are those? But they wanted one. Still, if you put salt in water, that water will become salty. It will not be good for human consumption. Colleagues, for that case, allow me give you the dangers. Now, I have said that potassium chloride is a salt. Am I on? Let me hope so. I am on. Potassium chloride is a salt. So its excess accumulation in water bodies results in formation of salty water. Excess accumulation of potassium chloride in water bodies causes salinization. Do you know what salinization means? Salinization is the condition where we have too much salt in water. So excess accumulation of potassium chloride in water bodies causes salinization. And salinization depletes oxygen levels within water bodies. It lowers the level of oxygen in water bodies. It also changes the pH of water and the temperature of water. Changes water temperature and the pH, hence making water not safe for human consumption. That can be mitigated by what? Practicing safe waste management practices of disposing of potassium chloride waste. Instead of just putting it in water, we can look at safe waste management practices like treating waste before they are disposed of. That is the first danger. Then the other dangers, I have said, potassium chloride is non-biodegradable. It is non-biodegradable. So how will you say that? You come and say that potassium chloride is non-biodegradable and its deposition on land, I think that one, I haven't formulated it very well. What can you say? Okay, you can say that potassium chloride salt is non-biodegradable, and when deposited on land or when disposed on land, it takes long to decompose. And this affects soil pH, soil structure, soil aeration, hence hindering plant growth. Can I repeat? Potassium chloride is non-biodegradable, and when disposed on soil or land, it takes long to decompose, and this affects soil structure, soil pH, soil aeration, which in turn lowers soil fertility, hindering plant growth. For the last time, potassium chloride is non-biodegradable, and when disposed on land, takes long to decompose, and this affects soil pH, soil structure, soil aeration, which in turn lowers soil fertility, hindering plant growth. That is one point which you can think about. Then another point, one can also link salinization to death of aquatic living organisms. You see, for the first point, I have said that salinization, you see, that look at that first point. Excess accumulation of potassium chloride in water bodies causes salinization, which depletes oxygen levels within water bodies, changes water temperature, pH, making water not safe for human consumption. So one can say that depletes oxygen levels within water bodies, causing suffocation and hence death of aquatic living organisms. Causing suffocation and hence death of aquatic living organisms. So those are other points which you can also as well think about. Colleagues, allow me stop this here.